Okay, this is section 1.7, part 2. In part 1, we solved polynomial inequalities. In this second part, we're going to be solving rational inequalities. Okay, what's a rational inequality? Well, it looks something like this. You have a fraction, which is made up of a polynomial in the numerator and a polynomial in the denominator. That's called a rational expression. And then you could have less than or equal to 0, less than 0, and we can change this less than sign to bigger than, less than or equal, bigger than or equal. It doesn't matter. But this, we could say that this inequality, this is a rational inequality in standard form when it's being compared to 0. Okay, so how do we solve these things? How do we solve a rational inequality? All right, the first thing you want to do is set it equal to 0. What that means is that there should be a 0 on one side of the inequality and a single fraction on the other. So this inequality right here is already ready to be solved. But if it's not, then you have to first set it equal to 0. Okay, your second step is you want to find the values that make the numerator and the denominator 0. You gotta be careful though. The values that make the denominator 0, those will never be part of the solution set. So if they happen to be present, they will always have parentheses. So that's step 2. You gotta set both the numerator and the denominator equal to 0. And find whatever values make the numerator and the denominator 0. Step 3. You plot the values that you found in step 2 on a number line to create intervals. And then step 4, you use a test value from each interval to determine which intervals form the solution set. So it's similar to polynomial inequalities. It's just that now you have to set the numerator and the denominator equal to 0 to figure out the values that will give rise to your intervals. Okay, so let's get on with it. Let's see. There are 3 rational inequalities to be solved. It's problem 6. You should write it down. This is problem 7 down here. Where is it? Sorry, my computer doesn't like recording videos. So this is the next rational inequality. You should write it down. And then there is also this rational inequality right here. You should write all of these 3 rational inequalities down and try to solve them on your own. And then let's compare answers. And express your solution using interval notation. So use interval notation to express your solution. Okay, so let's get on with it. Let's see, how do we solve these rational inequalities? So the first one, I'm gonna say step 1. So step 1, I'm going to set equal to 0. Okay, that means that I gotta have a single fraction on one side and 0 on the other. It doesn't matter on which side the fraction is or where the 0 is. I'm gonna leave my fraction on the left hand side, my 0 on the right hand side. I don't know. So in order to do that, what I'm going to do is this. I'm going to say 6 over x minus 3 minus 4 bigger than or equal to 0. Remember that if you multiply or divide by a negative, the inequality sign changes. So keep that in mind. We haven't done that yet, but I mean, if in your case you happen to multiply or divide by a negative, remember that you have to change the inequality sign. Okay. Now what I have to do on the left hand side is some arithmetic here. I have to subtract these fractions here. So I gotta get a common denominator. And it looks to me that the common denominator is x minus 3. So I'm gonna have this 6 over x minus 3 minus, I'm gonna say 4. And then I'm gonna have to multiply by x minus 3 and this over x minus 3. And that's bigger than or equal to 0. Okay, so this is so that I can get a common denominator. All right, So let me then actually carry this out. So this becomes 6 minus 4 times x minus 3 over x minus 3 bigger than or equal to 0. Let me distribute that negative 4. So 6 minus 4x plus 12 over x minus 3 bigger than or equal to 0. And then let me just collect like terms. 6 plus 12, that's going to be 18. So 18 minus 4x over x minus 3 is bigger than or equal to 0. Okay, I think, so that's what I mean by setting it equal to 0. First of all, that's our first step. So that was step 1. We just set our inequality so that one side is 0 and the other side is just a fraction. Okay, now let me get on to step 2. In step 2, what I'm going to do is I am going to set the numerator of this fraction equal to 0, the denominator equal to 0, and I'm going to find solutions to those equations. So I have 18 minus 4x equals 0, and x minus 3. So here I'm setting the numerator and denominator equal to 0. X minus 3 equals 0. This is going to give me the answer x equals 18 over 4, or 9/2. This is going to give me the answer x equals 3. Okay? So far so good. Now let me get into step 3. So step 3 says that I should plot these values that I found in step 2 on a number line. And that's going to create intervals for me. So I have 3. And by the way, all the values, so whenever you set the denominator equal to 0, those values will never be part of your solution set. So there's going to be always parentheses associated with those numbers. So right now at 3, come on. Sorry, give my computer a little break here. She's an old one, but a good one. So I'm gonna put an open circle there, so that's 3. 9/2. 9/2 is about, well, it's 4.5. And right now also look at the type of inequality that we're dealing with. That's a bigger than or equal. That allows for equality. So then the value that I get out of the numerator, those values are going to be solid dots. So I'm gonna put 9/2 over here. 4.5. Okay. So this creates 3 intervals for me. The intervals are negative infinity to 3. I have the interval 3 to 9/2. I am going to use a bracket on the 9/2. Notice that the 3 always has a parenthesis. That's because that's what makes the denominator 0. So we don't want that value. That value is not going to be part of our solution. And then we have 9/2 to positive infinity. Okay, and now what I gotta do is step 4 is just test values. So let me just give myself room here. So step 4. Test values. Okay, so let me pick a value from this interval. I don't know, let's say x equals 0. That one's easy. Let me pick a value from this interval, 3 to 9/2. 3 to 4.5. Well, I'm going to say 4. Let me pick a value in this interval. 9/2, 4.5 to positive infinity. I'll just pick 5. whatever makes my arithmetic easy. Now, what do I plug these values into? So I gotta plug these values into what? Into which inequality? It doesn't matter. Turns out that the original inequality that we started with, the original one, the one that wasn't set equal to 0, so this one all the way up here, we could plug it into that and see if it satisfies that, see if things are bigger than or equal to 4, or we can plug in our test values into this other equivalent form, the one that's set equal to 0. It doesn't matter which one you plug it into, you should get the same answers. So I am just going to plug it into this one that is set equal to 0. Let me just kind of write it down here so that I can see it. So I'm going to say 18 minus 4x over x minus 3 bigger than or equal to 0. That's the one I'm going to test into. Although it doesn't matter, you could test into the original one and we should get the same answer. So, okay, I've picked some values. Now I'm going to plug them into my inequality to test if it satisfies my inequality. So if x is equal to 0 and I plug it into my inequality, I'm going to end up with what? I should end up with 18 over negative 3, which is negative. It's a negative value. And so it doesn't satisfy my inequality because my inequality should be bigger than or equal to 0. So this interval does not satisfy my inequality. Let me think about the other x value that I chose from this other interval. 4. If my x is equal to 4, I'm going to have, and I plug it into my inequality over here, I'm going to have 18 minus 16, that's 2, over 4 minus 3. 4 minus 3 is 1, and that is definitely bigger than 0, so that satisfies, this interval satisfies my inequality. Let me look at this other interval and the value that we picked from this interval, x equals 5. If x is equal to 5 and I plug it into this inequality over here, I would get 18 minus 20. That's negative 2 over, and then I would have 5 minus 3, so that's 2, and well, that's negative. And so this interval is not part of my solution set. So my solution set consists of the interval 3 to 9/2. Notice that there's a parenthesis here because the 3 is what made my denominator 0. The bracket over here is because our inequality is non-strict, is bigger than or equal. Okay, so that is all there is. That is the solution for our first rational inequality. Hopefully you agree and we got the same answer. Okay. Let's move on to the next one. Same idea here. Same idea. It's just that now we have a different type of equal sign. Now we have a strict inequality. So everything will have parentheses for us now. Whereas up here, whereas in the previous one, we had a bigger than or equal. That's why we have brackets. So in this next example, everything is going to be parentheses. But it's the same idea. So let's begin. Step 1. Step 1 consists of setting equal to 0, we said. And some arithmetic. We're going to have to find a common denominator and make a single fraction. Set equal to 0. Okay, so let's do that. So that means I need to subtract a 4. So 3x plus 1 over 2x minus 3 minus 4 is less than 0. Okay, I need to do the arithmetic of the left part of this inequality. I need to subtract these fractions. I need a common denominator. And I think the common denominator is just the denominator of this fraction, 2x minus 3. Okay, so what that means is that I need to change my 4 to a fraction whose denominator is 2x minus 3. Okay, good. So now I can begin by, I can actually add these fractions into a single one. So this becomes 3x minus 1 minus 4 2x minus 3. Be careful with your signs. Notice that I put things in parentheses and I keep them in parentheses until after I combine the fractions. Okay, so that becomes 3x minus 1 minus 8x plus 12. Okay, all of this over 2x minus 3 less than 0. Let's give us some room here. Okay, let me collect some like terms. 3x minus 8x is going to become negative 5x, so negative 5x. Negative 1 plus 12, that's 11, over 2x minus 3, this is less than 0. Alright, so that's the end of step 1. There's a lot of arithmetic going on there. That's okay. Let's get into step 2. Now what I gotta do is I gotta set the numerator and the denominator of this fraction equal to 0. Alright, so negative 5x plus 11 equals 0. And 2x minus 3 equals 0. The top equation is going to give me the answer x equals, hang on here, There is an arithmetic mistake somewhere along the way. I just noticed. You see, I started with 3x plus 1, 3x plus 1, and for some reason I changed it to 3x minus 1 down here. So let me be careful with my arithmetic. So that should be a plus, that should be a plus, this is a plus, and so then I'm a little bit off here. So 3x minus 8x, that's okay. And then 1 plus 12, that should be 13. Oops. Let me erase computer. Sorry, technical difficulties. It's part of the job. So this is 13. Okay, so then my equation over here should be negative 5x plus 13. That would have been very different answers. Negative 5x plus 13 equals 0. That's going to give me the answer x equals 13 over 5. And this bottom equation gives me the answer x equals 3/2. Okay. So step 3. I'm gonna put these values that I found in step 2 on a number line. And right now, think about the type of inequality that we're dealing with. It's a strict inequality. So everything's going to have parentheses. The values that we have in the denominator always have parentheses. Because of the strict inequality, we're going to have parentheses. So everything deals with parentheses in this problem. So 3/2 is a little bit smaller than 13/5. So 3/2 is to the left. And this is an open circle. Both of them are open circles. So this is 3/2. This is 13/5. And 13/5 is 2.6. Just for reference, 2.6, and the other one's 1.5. Okay, now that has created 3 intervals for me. The intervals are negative infinity to 3/2. The other interval is 3/2 to 13/5, and 13/5 positive infinity. Good. Now we are at step 4. Now we need to do some testing. So step 4. Let's test. let me pick a value from this interval, negative infinity to 3/2. So I'm gonna just say 0, x equals 0. That one is easy to deal with, the arithmetic that comes out of that. From here, I'm dealing with values between 1.5 and 2.6. Well, I'm just gonna pick x equals 2. Things that are bigger than 2.6, well, I'm just gonna say x equals 3. Okay, and now into which inequality do I plug in these values? Should I plug them into this inequality that we got once we set equal to 0, or should we plug it back into the original one? It doesn't matter. Again, it does not matter. You could plug it back into the original one and we should get the same answer as if we plugged it into this equivalent one. I'm gonna plug it into the equivalent one just because it makes the arithmetic a little bit easier. Okay, so if I plug in 0 into this inequality right here, well, 5 times 0 is gone and 2 times 0 is gone, so I end up with 13 over negative 3. So 13, so if my x is equal to 0, I end up with 13 over negative 3, and that's negative. So that satisfies my inequality. Wow, my computer's really dumb when I'm recording videos. So if x is equal to 0 and I plug it into this inequality, I should end up with 13 over negative 3. 13 over negative 3, which is definitely negative, which is what we want. So this interval is good. Now if x is equal to 2, if x is equal to 2, I'm going to have negative 10 plus 13, so that's 3. And 4 minus 3, which is 1, and that's bigger than 0. Well, that's not what we want. We want things to end up being less than 0. So this interval we do not want. And if x is equal to 3, and I plug it into my inequality up here, I'm going to have 15, negative 15 plus 13, that's negative 2, over 6 minus 3, that's 3. That's less than 0, so that's good. So then it looks like my solution set is the union of this interval, negative infinity to 3/2, and 13/5 to positive infinity. So our solution is negative infinity to 3/2 with a parentheses union 13 over 5 to positive infinity. Okay, so hopefully we agree on that. Last example. This one's a little, just a lot of the same ideas. It's just maybe the arithmetic gets a little bit messier here because there's a few more x's to deal with, but it's the same procedure. So my step 1 again is to set this thing equal to 0. All right. So let me get on with that. So 3x plus 2 minus 5 over x is bigger than or equal to 0. I've subtracted the negative 5 over x. Now I gotta get a common denominator. What's a good common denominator for these two fractions? One of them has a denominator 3x plus 2, the other one has a denominator x. I would just say that a good common denominator for these two fractions is just the product of these two denominators. Okay, so then this left fraction, I'm going to multiply it by x and x in both numerator and denominator. And this right fraction, I'm going to multiply it by 3x plus 2 and 3x plus 2 in denominator and in the numerator. So this is what it's going to look like. Minus okay, so now I can combine these two fractions into a single one. Let me do that. So that becomes negative 5x minus 5 times 3x plus 2 over x times 3x plus 2 and this is bigger than or equal to 0. I shouldn't try to erase. I was just trying to make this line a little bit smaller because of aesthetics, but I guess that doesn't matter right now because my computer is not very collaborative here. Alright, so bigger than or equal to 0. Good. Now let me simplify this a little bit. So that's negative 5x minus 15x minus 10, and all of this over, well, I'm just going to leave it like this. I don't want to multiply out in the denominator. In the denominator, I'm going to leave it as is because eventually I'm going to have to set the denominator equal to 0. And right now that it's in factor form, that's already kind of good for me. I don't have to factor it later on. Okay, so let's see. Let me just one last step here. Negative, I'm going to say that this is negative 20x. Negative 20x minus 10 over x times 3x plus 2, bigger than or equal to 0. All right, so we're at step 2. In step 2, we got to set both the numerator and the denominator equal to 0. So negative 20x minus 10 equals 0. And I have that x, 3x plus 2 equals 0. The top equation has the solution x equals 1/2, negative 1/2. X equals negative 1/2. The bottom equation should have two solutions by using the zero product property. X equals 0 and x equals negative 2/3. Okay, now I have found three values here. So I have found these three values that make the numerator and the denominator 0. I'm going to put them all on a number line. Okay, so my number line is going to look like this. And also think about, 0 and negative 2/3, those are going to be using parentheses. Those are going to be with open circles. Negative 1/2 is going to be a solid circle because we're dealing with a bigger than or equal inequality. So let's see. So I'm going to make a little open circle here, if I can, if my computer wants me to. Come on, I want to erase. Jeez, come on. Sorry, I apologize for this. My computer is literally just humming right now. I don't know if you can hear it on the microphone, but my computer is not very happy about this. Okay, so that's an open circle, that's an open circle, and in between them, well, not in between them, but somewhere over here, it's going to be a closed circle. So I'm going to say that this is negative 2/3, this is negative 1/2, and this is 0 over here. I have put my values that I got from setting the numerator and the denominator equal to 0 on a number line. That creates 4 intervals for me. One of them is negative infinity to negative 2/3. The other one is negative 2/3, negative 1/2 with a bracket. The other one would be bracket negative 1/2 to 0. And the other interval would be 0 to infinity. Okay. And now what I'm going to do is I'm going to pick values from each interval and test them. So this is, we're getting here into our step 4. Okay. So let me think something on the interval negative infinity to negative 2/3. I'm just going to say x equals negative 1. Something on the interval negative 2/3, negative 2/3 and negative 1/2. That's like negative 0.666 all the way to negative 0.5. Well, what about negative 0.6? Negative 0.6 is right between there. And negative 0.6 turns out is negative 3/5. So negative 3/5. I'm going to choose negative 3/5. Something between negative 1/2 and 0. Well, what about negative 1/4? Negative 1/4. And over here, something that's bigger than 0. Well, I don't know, x equals 1. Okay. Now I got a test. I'm going to plug in my values that I picked from each interval into this inequality up here. So let me pick x equals negative 1. If x is equal to negative 1, and I plug it up here, I'm going to have negative 20 times negative 1. That's positive 20. So that's going to be 20 minus 10. So that's 10. That's 10. And in the denominator, I'm going to have negative 1 times negative 3 plus 2. Well, that's negative 1 times negative 1. And well, this is going to be positive. So that's good, because we want to be bigger than or equal to 0. So that's good. Now, I'm going to let you verify the other intervals here. I'll let you do the verification on your own. So I'm just going to tell you what the solution set is. The solution set is going to be negative infinity to negative 2/3 union negative 1/2 to 0. You should verify that that's true. You should plug in these test values, all the other corresponding test values, into the inequality and make sure that it satisfies the inequality. And you should conclude this answer here. Negative infinity to negative 2/3 union negative 1/2 to 0. Okay, so that is all for 1.7. Thank you, and I'll see you in the next video.